Hello everyone, I am Rakibul Hasan Khan, Assistant Professor of Assam Downtown University. Today I am going to discuss about lens neutralization by hand. So, what is neutralization? The power of an unknown lens can be determined by neutralizing it with other lens of known power. Neutralization is based on the fact that if we look at an object through a convex or concave lens and move the lens from side to side, right and left or up and down, the image that we see through the lens will also move. If the lens has no power or has been neutralized by placing a lens or equal power but opposite sign against the unknown lens, then there is no image movement. So here neutralization means we will determine the power of unknown spectacle lens power by the known power. So here we will move the lens up, down, right and left side, and at the same time we are noticed that the image will move or not. If the spectacle lens have zero power or neutralized by some other equal power, then there is no image movement. Next, steps in neutralization. So number 1, draw a cross line. On a piece of paper, draw a cross with lines perpendicular to each other and at least 15 centimeter long. See the diagram, like that we will make a cross lines and we will put it at least 15 centimeter away. Next, number 2, determine principal meridian. Look at the cross through the lens. The farther away the cross is from us during this task, the better the other end of the room. Rotate the lens to determine if there is astigmatism by observing for scissoring movements of the cross image. If there are no scissoring movements, the lens is spherical. That means there are no principal meridian. Here, for better performance, we will keep the cross line other end of the room. After that, rotate the lens and we observe that there is scissoring movements is present or not. This is scissoring movement. See the diagram, scissoring movement. If there is no scissoring movements, that means the lens is spherical. Next, if scissoring movements are present, then rotate the lens such that the cross lines of the image are exactly perpendicular. That is, they line up with the cross lines of the object cross. This is the orientation of the principal meridian of the lens. We can now mark the principal meridian of the lens with spots using a flat tip pen. Keep the lens in this orientation for the remainder of the task. See here, if scissoring movements are present, then rotate the lens until the object cross and the cross line. This is cross line and this is object cross. They are line up with each other. After that, we will mark the principal meridian in our lens by removable marker. Next, number 3, determine the optical center. Optical center means center of the lens. Hold the lens as in step 2 above, that is with the cross lines of the image perpendicular to each other. See the diagram, this is scissoring movements and this is cross line. This is cross line. We will move the lens like that, rotate or move the lens until they are line up with each other. See the diagram like that. Next, now move the lens up and down or side to side to ensure that the lines of the cross image exactly overlap with the lines of the object cross. Held in this position, the point at which the cross lines intersect on the lens is the optical center of the lens. Mark the optical center with a flat tip pen. Neutralization of the lens should occur at the optical center. Here, now move the lens up and down and right and left side to confirm that object cross and cross line they are exactly overlap or not. And after that, hold the position where the point both cross lines are intersect on the lens. Yeah, this point. This is the optical center. Mark there by removable marker. Next, neutralize each meridian, holding the lens in orientation with its principal meridian horizontal and vertical as in step 3. Move the lens from side to side. Next, if there is with movement, the lens is minus along this meridian and we require a plus lens to neutralize. If there is against movement, the lens is plus along this meridian and we require a minus lens to neutralize. See the diagram, this is minus lens and this is plus lens. So when we move the lens, then the object will move with the lens. Same thing in plus lens. When we move the lens, the object will move the opposite direction of the lens. So in minus lens, if the power is minus 2 diopter spherical, then we will neutralize plus 2 diopter spherical. Same in plus lens, if patient have plus 2 diopter spherical, then we will neutralize that opposite sign minus 2 diopter spherical. Next, using a bracketing technique, find the lens that achieves neutralization along this meridian, that is no movement, and remember that the power of the unknown lens is the same size but opposite in sign to the neutralizing lens. Once the horizontal meridian is neutralized, we can move the lens up and down to neutralize the vertical meridian or vice versa. Next, number 5, draw a power cross. The power of the unknown lens along the meridian tested is the same as the power of the neutralizing lens but opposite in sign. Thus, for a lens with meridian at 90 degree and 180 degrees, if a plus 2 diopter lens was required to neutralize the vertical meridian, then the power in the vertical meridian 90 degrees is minus 2 diopter. See the diagram. This is 90 degree. Here minus 2 diopter spherical power is there. So this meridian we will neutralize by plus 2 diopter. And if a plus 3 diopter lens was required to neutralize the horizontal meridian, then the power of the lens in the horizontal meridian is minus 3 diopter. See the diagram. This horizontal meridian having minus 3 diopter. So this horizontal meridian we will neutralize by plus 3 diopter. Next, convert to sphero cylindrical formula. Convert our power cross into a sphero cylindrical formula in the standard manner. Thus, for the power cross in the example above, minus 2 diopter at 90 degree and minus 3 diopter at 180 degree. The sphero cylindrical formula is here. We are taking the small value, that is minus 2 diopter, this one minus 2 diopter for spherical power, this one spherical power minus 2 diopter spherical power. After that we will take the difference value of both meridian. Difference value means minus 2 diopter and minus 3 diopter. We will take the difference value, that is 1 diopter. How? Minus 2 diopter plus in the bracket minus 3 diopter, or after calculate we will find minus 1 diopter, and we will give minus sign because of we will take the sign from the bigger value, this one, and we will take the axis which one we are select for spherical, that is 90 degree, because -2 diopter we are taking for a spherical, so we will put here 90 degree. So the final power is -2 diopter spherical oblique -1 diopter cylinder into 90 degree. Hope you all understood the lens neutralization by hand. Thank you.